Hello, welcome to our video lecture for this week. In this section of the lecture we're going to cover OLEDB, ADO.net, and ASP.net. Please remember that this is copyrighted. OLEDB stands for Object Linking and Embedding Database. Microsoft developed this API in the 90s. OLEDB encapsulates data server functionality. OLEDB offers us advantages. Even though it does encapsulate data server functionality, it's not exclusively for accessing relational databases. It can be used to access other data types as well. Programmers can use several programming languages, such as C, C#, and Java. There is a drawback, however. Some languages, such as Visual Basic, are not as accessible. In part to overcome this drawback, Microsoft developed Active Data Objects, or ADO. The objects help us utilize OLEDB, and were designed so that any language could use ADO and utilize OLEDB, even those languages that could not utilize OLEDB before. Microsoft improved upon ADO when it developed ADO.net as part of its .NET initiative. Just to be sure that everyone is clear, ADO.net and ASP.net are completely different animals. ADO.net is a framework for accessing databases, while ASP.net is a framework for building web applications. They may work together, and in fact often do, but they serve completely different purposes, so please don't get them confused. ASP.net is part of the database processing environment and part of the Microsoft .NET framework. To access databases, ASP.net relies upon ADO.net. ASP.net is used in web pages when creating web-based database applications. It also uses other .NET languages, including HTML, C#, Visual Basic, and JavaScript. When we create web pages in ASP.net, we can give them the capability to read and write database data. This data can be transmitted over networks using standard Internet protocols. When we begin transmitting data over the Internet, we do open up a larger attack surface, and web-based data applications are no different. We do create many web pages to access data, and many of them allow user input of some sort. Whenever we have user input, we have a security vulnerability. A very common attack is an SQL injection attack. In these attacks, malicious SQL commands are issued to the database via some web interface, such as a web form. When users enter information in web pages, they are allowed to bypass the firewall so they can access the database. Attackers know the firewall is bypassed, so they attempt to attack the database by entering malicious SQL commands in the input boxes in web pages instead of entering the expected data. For example, the example in your book shows an SQL statement here where we are looking for an input from the user. When the user inputs their phone, they may enter some malicious command, such as this SQL command, and not just their phone number. If we don't check their input data, then we can be in big trouble. We must always put checks in place for all user input. A good rule of thumb is to never trust any input from any user. If there's anything that can go wrong, it will likely go wrong with user input. We should validate all user input and not simply trust it to be a part of our database. Some of this input might not be malicious, it might not be an injection attack, but if it is incorrect input, it can cause problems in our database anyway. Thank you for your attention. This concludes the first segment of our video lecture for this week. Goodbye. Hello. Welcome to our second segment of our video lecture for this week. In this segment, we'll begin to look at XML. Please remember that this is copyrighted. XML is a standard means for defining the structure of documents and for transmitting documents from one computer to another. So, what does this have to do with databases? Database processing and document processing actually need each other. For expressing database views, database processing uses document processing, and to be able to store and manipulate data, document processing needs database processing. Since one of the main uses for XML is communicating documents over the internet, and since many websites need to display and update data from databases, the two go hand in hand. XML actually stands for Extensible Markup Language. It was developed in the 90s as a subset of SGML, which means Standard Generalized Markup Language. For reference purposes, I want to point out that HTML, the language used to create many web pages, and also that has been used in several examples in your book, is also an SGML-based language. XML has become somewhat of a hybrid, document processing and data processing. If we have an XML document, database data can automatically be extracted from it. Likewise, we can automatically generate XML documents from database data. We can use XML to describe, represent, and materialize database views. You might wonder why we use XML instead of HTML, since both are SGML based and HTML has already been so widely used. XML is much better than HTML for database applications. With XML, we get a separation between structure and content, which we don't get with HTML. Also, although XML is standardized, it's still extensible, which means developers can add to it. We can create tags that actually describe the data, unlike HTML, in which you can only use the tags that are already in the standard. We can see why this is especially important when we think about the different types of data that is stored by different organizations. For example, the data stored for student records at a school is quite different from that stored for account records at a bank. We'll see a better example of this later. Additionally, XML tags can only be used for the purpose for which we meant them, unlike HTML tags, which can be used for multiple purposes. As we see in this example, we can generate XML with an SQL query. Here we're using the select asterisk query. This will select everything. To generate the XML, we're using the for XML clause. To see the full results, we will click on the single cell that is returned. Once we click on it, the results will display. The results show both the XML tags in the red and the data that was returned in the black. The XML tags describe quite well the data. We'll see a better example of this in our next segment in just a moment, so that you can see more clearly what these tags say and what the data represents. We'll also understand what the boxes in front of the tags mean. At this point, we'll conclude this segment and begin our example with the next segment. Thank you so much for your attention. Hello, welcome to our third and final segment of our video lecture for this week. In this segment, we're going to look at an XML example, and we're going to touch on XML web services. Please remember that this is copyrighted. In our previous segment, we ended with an example that was in your book, where we used SQL to process XML. Right, we ended up with an SQL statement, select and the asterisk, meaning, remember, select all, and we used the for XML clause so that we would produce an XML result. Our result was produced here in one cell, and when we clicked on that result, we ended up with the full result displayed on our screen. This result is a little bit hard to see, so I've made up a small example of XML so that we can see the result and discuss a little bit more about what this result shows us. Here's our example of our XML code, and I wanted you to see this just so that you can see the code looks almost like the result. When we run this code, before I run this code, I do want to point out I simply typed the information into this code. I did not access a database for this for the sake of time. Now, when I run this code, the result that I get looks very similar to the result in the example in your book. We have the tags in red and the information in black. Let's look at this result so we can see what all this means. The red is what the tag is, and that's what's describing our information. We know that 100 meter dash means it's meet event 1. We know that 1 is the runner ID, and this runner's name is Joe. We know this is a boys team. This XML is for a track team. We know this is a boys team. I could have actually named it boys track team if I had wanted to. Okay? All right. Each of our tags describes what our information is. And notice that our result looks an awful lot like the code. That's by design. Okay? Another thing I want to point out, on your example in your book, you notice these small little boxes here. Okay? On our example, I'll show you what those do. With these, in this case, instead of the box around it, it's simply the dash. You can hide some of the results if you want to, so that you can simply focus on another portion of the result. In this case, I only wanted to look at my runner 2, so I hid my runner 1 so that I could focus on runner 2. We can hide all. We can even hide the entire result if we want to discuss it with someone and just open it as we discuss, so that the focus will be on one section. Okay. This was my XML example, so that I could hopefully show you a little better what was shown in that small picture in your text. Now, let's look at XML web services. These services allow application functionality on one web server to be shared with web applications on other web servers. They involve several standards. Some of these standards include XML, which we have looked at, and another standard called SOAP, or S-O-A-P. SOAP stands for Simple Object Access Protocol. It is an XML-based standard, and it's a standard protocol for communication. We send messages of any type, and we can do this using any protocol over the internet. It's not restricted. The advantages to using SOAP as part of these XML web services, and part of the reason why SOAP was chosen, is because it can get past fast firewalls, so we will be able to access our data. Additionally, since SOAP uses XML to format data, it is extensible. Recall, that means we can add to it when we need to. Also, because it uses XML, it is quite well supported, so we don't have any support issues there. There are other protocols used in these, but these are the two main ones we want to focus on because they are two of the most common ones you will come in contact with. This concludes this week's video lecture. Thank you for your attention.